Hi everyone, welcome to another free online class from AIMS Study Center. This time around, we are really trying to crack set examination which is on due on January 2022. We have two questions clearly here. The first one is which was asked on set 2021 which was conducted quite recently, and the other one is from the higher secondary school teacher examination which was conducted on 2012. Both the topics are integration, and we are really going to try how to solve these questions. So when we move to the first question, the question is integral 0 to pi dx divided by 1 plus 3 raised to cos x, and the options are 2 pi, pi by 2, pi and none of these. So let's try to solve these particular questions using the results that we have in our plus 2 examinations. So the result is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So this result is going to help us to solve this particular problem, which is integral 0 to pi dx by 1 plus 3 raised to cos x. And you should know some prelims about trigonometry, then only you can crack this particular question. So the property is like this. So this, when we convert this thing into this integral, here a is equal to 0 and b is equal to pi. So the question will become this integral 0 to pi f of x dx, that's dx by 1 plus 3 raised to cos x here, which is equal to integral 0 to pi dx divided by 1 plus 3 raised to cos of pi minus x. So as I mentioned, if you don't know anything about trigonometry, you will be really in trouble to solve this particular problem. But in this case, it's a very simple result. Since cos of pi minus x is minus cos x, we can write it further as integral 0 to pi dx divided by 1 plus 3 raised, since cos of pi minus x is minus cos x, we can write it as 3 raised to minus cos x. So what do you mean by 3 raised to minus cos x? This can be further written as integral 0 to pi dx divided by 1 plus 1 by 3 raised to cos x. So which is dx divided by 1 plus 1 by 3 raised to cos x, and this can be written as integral 0 to pi 3 raised to cos x divided by 1 plus 3 raised to cos x. When you take the LCM, you will get like this: integral 0 to pi 3 raised to cos x dx divided by 1 plus 3 raised to cos x. So these two integrals are same. Which integral? This one, integral 0 to dx 1 plus 3 raised to cos x, is same as integral 0 to pi 3 raised to cos x 1 plus 3 raised to cos x. So when we add those two integrals, suppose I am naming it as I, so we are adding this both integrals, integral 0 to pi dx, which is equal to integral 0 to pi dx by 1 plus 3 raised to cos x, plus again integral 0 to pi 3 raised to cos x divided by 1 plus 3 raised to cos x dx. So what you will be actually getting in the LHS will be 2i, and you will have dx plus 3 raised to cos x divided by 1 plus 3 raised to cos x, which is 1 plus 3 raised to cos x by 1 plus 3 raised to cos x, which is 1. So you will have integral 0 to pi dx. And what is integral 0 to pi dx? Is pi. So you will get 2i is equal to pi, and you will get the answer I equal to pi by 2, which is in option, which is the option B. So you have solved this whole thing by using the simple identity integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx, and your answer is pi by 2, which is option B. So that's about the first question when you know the property of integration. So when we move to the next question, which is very simple question, but when we first when we have the look first at that thing, we'll be feeling it to be very difficult. Now what is there in the second question, which was asked in higher secondary school teachers examination 2012? The question is about integral 0 to pi by 2 log tan 1, tan 2 into etc. tan 89 dx. So when you look at these particular questions, you don't know about tan 1 degree, you don't know about tan 2 degree, and you don't know about tan 89. But one thing you have to apply here is the complementary property of tan and cot. And what is complementary property? That is tan of pi by 2 minus theta is equal to cot theta. So this tan 1 can be written as cot 89, or this tan 89 can be written as cot 1. Okay, that we will discuss in the continuing video. So let's analyze this question again and we will move to the answer. Okay, the question is about to find the integral from 0 to pi by 2 log of tan 1 degree, tan 2 degree, etc. tan 89 degree, and which was asked in higher secondary school teacher examination 2012. And you have got 4 options. First option is 1, the second option is 0, the third option is pi by 4, and the last and final option is not defined. And mostly people goes for the last option because we all know that tan 90 is not defined. But when you look at this whole question, there is nothing to integrate for you, because integral 0 to pi log of tan 1 into tan 2 into etc. up to tan 89 is a particular constant. We don't know that constant. We are really trying to crack and find out what's the constant. So you have to know 2 results, and the first result is tan and cot are complementary. Tan and cot are complementary. That means tan angle and cot angle are complementary, and you have this also result tan x into cot x is equal to 1. Once you have these 2 results, then it's very simple to crack this question. I will show just an example. I am taking tan 1 degree and I am taking tan 89 degree. So what happens? Tan 1 degree is same as tan of 90 minus 1 degree. If I am right, it is tan of 90 minus 1 degree, or sorry, tan of 89 degree is equal to tan of 90 minus 1 degree. So what is tan of minus 90 minus theta? Since tan and cot are complementary, you will get it as cot 89. Or tan of 90 minus 1 degree as cot 1 degree. So this tan 1 degree and this tan 89 degree can be multiplied such that tan 1 into cot 1, which is equal to 1. We know that tan x into cot x is equal to 1. Similarly, the term which is presiding tan 89 degree will be tan 88, and we will be having tan 2 here. So tan 2 into tan 88 is also 1, and moving continuously like that you will reach a tan 45, and we know that tan 45 is also 1. So the whole thing will become log of 1 into 1 into 1 into etc. So which means it is log 1. So the whole integral will become integral 0 to pi by 2 log 1 into dx, and we all know that log 1 is equal to 0, so we don't want to integrate this thing, because 0 into any integral is 0 itself. So this will become integral 0 to pi by 2 0 dx, which is equal to 0, which again option B. I think you people have really followed these 2 questions properly, and I am really happy to announce that we will be conducting these type of classes continuously from this week. And for the better experience of mathematics, especially to crack set examination, please do subscribe this channel and touch the bell icon. As well as if you need to contact us, please do contact us in the number that is given below in this particular video. Thank you very much.